Hi everyone, in this video we will take another indeterminate forms. We have 0 to the 0, infinity to the 0 and 1 to the infinity. In these three cases you have to take the len for the inside function. After that you have to use the Hopital rule, and to get the final answer for the original limit you have to take e for the answer you have to get the final answer of our limit. So for the first part we have limit 1 plus 3 over x to the x when x goes to positive infinity. To find the solution of this one, first you have to replace x by infinity to check if it's okay or not. Now 1 plus 3 over infinity, 3 over infinity equal to 0, so we have 1 inside the bracket to the power infinity. So 1 to the infinity is one of these cases, so you have to take len for the inside function. Our limit will be limit len of 1 plus 3 over x to the x when x goes to positive infinity. Then you have to put the power down. This is one of the properties of the natural logarithm. So you will have limit x multiplied by len 1 plus 3 over x when x goes to positive infinity. Now if we replace infinity here, you will get infinity multiplied by len of 1 plus 3 over infinity. 3 over infinity is equal to 0, and 1 plus 0, 1, and len of 1 equal to 0. So also infinity times 0 is one of the indeterminate forms. So you have to write x as 1 over x and put it down. So you will get limit of len 1 plus 3 over x over 1 over x when x goes to positive infinity. Now by direct substitution we have 1 plus 3 over infinity, so 1 plus 0 we have len 1, so we have 0 divided by 1 over infinity, which is 0. So we can use Hopital rule now. But before we did that, okay, we can simplify or use a special substitution to reduce the function. Okay, so you can put u equals 1 over x. So when x goes to infinity, u goes to 1 over infinity. So we have u goes to 1 over infinity, which is 0 from right. So we have limit len of 1 plus 3 over x, it means 3 times 1 over x, which is 3u, divided by 1 over x u when u goes to 0 from right. So I did a special substitution and we reduced the function inside the limit. Now also by direct substitution you will get 1 plus 0 len 1, 0 over 0, you will get the same thing here. So you can use Hopital here. So you have to find limit f prime over g prime. We have limit, the derivative for numerator is 3 over 1 plus 3u divided by the derivative of denominator, which is 1 when u goes to 0 from right. So this is equals to 3 over 1 plus 0, 3 over 1 plus 0, which is equals to 3. This is limit of len, the inside function. So the final step, you have to take e to get the final answer of our original limit. So this limit equals to e to power 3, and this is the final answer for this limit. For the second part, we have limit x to the power 1 over len of x when x goes to 0 from right. So firstly, you have to use direct substitution, and you will get 0 to the power 1 over len of 0 from right. So we have 0 to the power 1 over negative infinity, which is 0. So 0 to the power 0 is one of these indeterminate forms. So you have to take len for the inside function, and we have limit len x to the power 1 over len of x when x goes to 0 from right. Now this is a power, so you have to put it down as a property of natural logarithm. So we have limit 1 over len of x multiplied by len of x when x goes to 0 from right. By simplifying, you can cancel this one with this one, okay, and you will get 1 inside. So this limit equals to 1. So the final answer, or the final step, is to take e for this one. So we have e to the power 1, which is equals to e. In part C also we have 1 plus sine x to the power 1 over x. So by a direct substitution, we have 1 plus sine 0, which is 1 to the power 1 over 0, which is infinity. So we have the indeterminate form 1 to the power infinity. Take len for the inside function. You will get limit of len 1 plus sine x to the 1 over x when x goes to 0. Put the power down, you will get limit 1 over x times len of 1 plus sine x when x goes to 0. By a direct substitution, you will get 1 over 0, which is infinity, times 1 plus 0 len 1 plus 0 equals to 1, and len 1 equal to 0, and this is an indeterminate form, so you have to continue and make it 0 over 0. So we have limit, we can rewrite this one as len 1 plus sine x over x when x goes to 0. Now by a direct substitution also, we have 1 plus sine 0, so we have 1 plus 0, 1 len of 1 equal to 0 divided by 0. So we can use Hopital rule directly. and by Hopital rule you have to find the derivative up and down. Derivative up is cosine x over 1 plus sine x over the derivative of denominator, which is 1 when x goes to 0. Now by a direct substitution, cosine 0 equals 1, divide by 1 plus sine of 0, which is 0, and 1 plus 0 equals to 1, divide by 1. So this quantity equals to 1. So you have to go to the final step, which is you have to take e to get the final answer of the original limit. So this limit equals to e to the power 1, which is equals to e. In part C, we have limit len of x to the power 1 over x when x goes to positive infinity. Direct substitution, len of infinity equals to infinity, and 1 over infinity equal to 0. So we have one of these indeterminate forms. Take len for the inside function. You will get limit of len of x to the power 1 over x. Put the power down. You will have limit 1 over x times len of len x when x goes to positive infinity. Then rewrite the function inside as len of len x divided by x when x goes to positive infinity. By direct substitution, we have len of infinity, which is equals to infinity. So we have len of infinity also equals to infinity over infinity. So we can use the Hopital rule. So we have limit of derivative up, which is 1 over x over len x. So we have 1 over x times len x divided by the derivative of denominator, which is 1 when x goes to positive infinity, and we have limit 1 over x multiplied by len of x when x goes to positive infinity. Now by a direct substitution, we have 1 over infinity times len infinity, which is also infinity. So we have 1 over infinity, and this is equal to 0. So our limit equals, you have to take e as a final step. So we have e to the 0, which is equals to 1. In part D, we have limit x to the sine x when x goes to 0 from right. By a direct substitution, 0, we have 0 to the power 0 because sine of 0 equal to 0. So we have this indeterminate form. So you have to take len for the inside function, and you will get limit of len x to the sine x when x goes to 0 from right. After that, you have to put the power down, and you will get limit of sine x multiplied by len of x when x goes to 0 from right. By a direct substitution, sine of 0 equal to 0 multiplied by len of 0 from right equals to negative infinity. So we have also an indeterminate form, so you have to convert it as 0 over 0 or infinity over infinity. It depends on the question. So we can solve it by write the limit as len x over 1 over sine x when x goes to 0 from right. Also, by a direct substitution, len of 0 from right equals to negative infinity over 1 over sine 0, which is 1 over 0 give us infinity. So now we can use Hospital rule. But before you use Hospital rule, you can rewrite 1 over sine x as cosecant x. So we have limit len of x over cosecant of x when x goes to 0 from right. So you have to find limit of f prime over g prime. So we have limit the derivative of len x equals 1 over x divided by the derivative of cosecant is minus cosecant x cotan of x when x goes to 0 from right, and we can write it in one denominator. So we have limit 1 over x cosecant x times cotan x when x goes to 0 from right. Now move cosecant x up, it will be sine x, and move cotan x up, it will be tan x. So you will have limit negative sine x times tan x divided by x when x goes to 0 from right. And as you know that limit sine x over x equals 1 over 1. So we have negative 1 multiplied by tan of 0, which is 0. So we have the answer 0. Then we will go to the last step, and you have to take e for 0 to get the final answer of our original limit. So our limit equals to e to the power 0, which is equals to 1. In part E, we have limit x to the x when x goes to 0 from right, and by direct substitution we have 0 to the 0. So we have this indeterminate form. So you have to take the len for the inside function, and we have limit len of x to the x when x goes to 0 from right. Now put the power down, you will have limit x len of x when x goes to 0 from right. By a direct substitution, we have 0 times len of 0. So we have 0 times negative infinity. So we have the indeterminate form 0 times infinity. And you have to rewrite x as 1 over x in denominator. We have limit len of x over 1 over x when x goes to 0 from right. Also by a direct substitution, we have len 0 from right, which is negative infinity, divided by 1 over 0 from right equals also infinity. So we can use Hospital rule directly. Limit f prime over g prime. The derivative up is 1 over x, and derivative down is negative 1 over x squared when x goes to 0 from right. And this is equals to limit 1 over x multiplied by the reciprocal here, which is minus x squared when x goes to 0 from right. By simplifying, we have limit negative x, and when you substitute 0 you will get 0, so this is equal to 0. By simplifying, firstly you will get minus x, so minus 0 equal to 0, Now we'll go to the next or to the last step. So you have to take e for the answer you have, and you will get e to the power 0, which is equal to 1, and that's it. Thank you.